Many of you might have heard of RAID but aren't quite familiar with it. Let's start with a brief overview. RAID stands for Redundant Arrays of Independent Disks. It comes in various levels, with RAID 0, RAID 1, RAID 5, RAID 6, and RAID 10 being the most common. RAID 0 strips data across all disks, effectively doubling read and write performance. However, if one disk fails, all data is lost. Although RAID 0 increases the risk of data loss, it can be useful in applications such as caching. RAID 1, also known as disk mirroring, stores identical copies of data on all disks. This means that as long as at least one disk remains operational, your data is safe. RAID 1 can double read performance, but write performance remains similar to that of the single disk. RAID 5 requires at least 3 disks. It uses one disk space for parity, offering improved performance and security over a single disk, though not as robust as RAID 1. It's considered a balanced option. RAID 6 is similar to RAID 5 but requires at least 4 disks and uses 2 disk space for parity, providing higher security than RAID 5. RAID 10 combines RAID 1 and RAID 0, offering the features of both. It mirrors the data first, RAID 1, and then strips it, RAID 0, providing both high performance and redundancy. Let's get back to the main topic. We are going to configure 24 disks into a RAID 0 array. Note that this is a hardware RAID, not a software RAID. Hardware RAID uses dedicated hardware to manage the RAID functionality. In this case, I am using a PERC H330 mini controller card and the Mega CLI command to create a RAID. Software RAID, on the other hand, uses software to manage the RAID, with the mdadm command commonly used in Linux for this purpose. Using Mega CLI, I created a RAID 0 array with 24 disks in write-through mode, which means data is written directly to the disks without being cached. This setup gives us a 24-disk RAID 0 array with a total capacity of 26.2 TB, derived from 24 disks of 1.2 TB each. Some of you may notice that 1.2 TB multiplied by 24 equals 28.8 TB, not 26.2 TB. This discrepancy arises from the difference in how disk manufacturers and operating systems calculate capacity. Disk manufacturers use decimal notation, where 1 TB equals 1000 GB, whereas operating systems use binary notation, where 1 TB equals 1024 GB. Therefore, the capacity of these 24 disks is calculated as 1.2 times 1000 to the power of 4 divided by 1024 to the power of 4 times 24, which equals 26.19 TB, rounded to one decimal place as 26.2 TB. Now, let's test the performance of this 24-disk RAID 0 array using the FiO2. The results are as follows. 4K random write, 1192 IOPS. 4K random read, 1236 IOPS. Sequential write, 3889.5 MB per second. Sequential read, 4644.3 MB per second. Compared to a single disk, the 24-disk setup achieves approximately 3.5 times the performance in 4K random writes, 2.9 times in 4K random reads, 18 times in sequential writes, and 23 times in sequential reads. That's all for this video. If you enjoyed it, please hit the like button below, subscribe, and share. Feel free to leave your comments or questions in the comment section below.